This is another representation of the same thing. Here is a /8. That means that 8 bits are on and all the rest are off. So that means that it's 255 and then all zeros. A /16, that means there's 16 ones and 16 zeros. So it's 255, 255, 0, 0. /24 has 24 ones, and here's your mask here. /25 has that one more bit that makes it 128. /26 has another additional bit, so it's 192, and you just see the progression of ones going down here. And again, we don't go further than /30, so that's the last mask that you will have. One more quick representation here. We have a /8 again. We have 8 bits. And just as we saw before, the number of bits continues to increase depending on what the bit prefix is. And this is a good representation of how many hosts. So we've been looking at a /24. So you have available 254 hosts. Remember, I had a range from 0 through 255. Well, that's a total of 256, but you want to remember to subtract 2 because one is reserved, the very first one is reserved for the network, the very last one is reserved for the broadcast address. So as you use more bits, the number of hosts go down. If it was a /23, you actually have double the 254, of course, subtracting. It's actually 256 minus 2. So this would be 512 minus 2 is 510. 1024 minus 2, and so on. All right, so let's get subnetting. We have our hosts in order from most to least, and here's a chart that you will have to fill out, and it helps you to do subnetting. Okay, so the very first column is for hosts. We put them in order from most to least. Then we look at the chart down here, and you see that you have 100 hosts, and you need 128. I'm sorry, you need 100 hosts, and here there's 128 if you use a /25, so that is actually a good bit prefix to use. Okay, so what we do is we put the bit prefix next to the hosts. So since a /25 gives you 128 hosts, then you just put the bit prefix right next to it. Okay, what about 20? Can we use 128? We could, but that's way too much. So what about 64? What about 32? That sounds better. Let's see if we can go a little lower. Well, 16 is not enough. So we have to use a /27. So we go ahead and put our /27 here. And our next amount of hosts that we need is 10. So then we look on our chart here. 8 is too small. So 16 would work out great. So we're actually going to use a /28. Okay, the next one is 2 for HR. Now remember, don't get distracted with the 2 here, because remember, we always need to add 2, one for the network, one for the broadcast. So we're actually going to use a /30 here. Okay, so now that we know what the bit prefix is, remember the bit prefix tells you what the mask is. So we look on the row for mask. Now we're using a /25, so we're going to use 128. But what does that mean? Do we just put 128 here? No, we want to put the full mask. So remember that we have all ones, and all ones is a /24. And then we have all zeros at the end. Well, we don't have a /24. And also notice that all ones is 255, all ones 255, all ones 255, all zeros is 0. So we know we're using a /25, so we definitely have 24 ones. So let's go ahead and put that here. So it's all 255 here. So there's 8 ones, 8 ones, and 8 ones. Now, what happens in this last octet here? Well, that's what we're working on down here, the last octet. Now remember, a /25 is what we were using. We put /25 here. So that means that the last octet will be 128. Okay? I'm sorry. Okay. Now we're using a /27. So we go on this chart here. A /27 will give you a mask of 224. So we put your 255 again, 255, 255, 255 again. And we know that it's a 224 for /27. So we put 224. Same thing for /28. We know we have all ones. And then the last octet is 240. A /30. Again, we have 24 ones. And then we have 6 more. And that will give you a 252. So now you know what the mask is. You know what part represents the networks and what part represents the hosts. This is the network part, all the ones, and of course we're using a /25, a /27, and a /28. So now it's not all zeros because we're subnetting now. We're using, or we're making the networks conform to what we need it to do. So we have just determined what the prefixes are and what the masks are. So this is bit prefix and subnet masks. Okay, so let's move on. And what we want to move on to is the network addresses, the broadcast addresses. Remember, the network addresses are the very first, broadcast is the very last. Then we have a range, and we're just going to put the very first of the range and the very last of the range. Okay, so network address. Remember at the beginning, we were given this to work with. So this is our network address. And this actually is the very first network address here because that's what we can start with. Okay, so we have a network address, and then we're going to have a host, the first host, the last host, and the broadcast. But how do we get those? Well, we want to create a range, but how would we get the ranges of a /25? How do we know what it is? Well, remember, when you're using a /24, you have the last octet to work with, the entire octet. So that means you have from 0 through 255. You have a total of 256 addresses, minus 2 will give you the hosts. So, but what about a /25? A /25, basically every time you use one more bit, you're going to divide the network in half, or you're basically doubling the amount of networks. So if you have a /24, you have 0 through 255. you have a /25. Now you divide it in half, and your ranges are now 0 through 127 and 128 through 255. So we know that we are using this address as a network address, the very first address. And so here's our range here that we're going to use. So the very first one is the 0, and the very last one here is a 127. So that would be the broadcast. So it's 192.168.1.127. That is the broadcast address. Remember, the first is the network, the last is the broadcast, and then we have the range in between. Well, what is the first address right after the network? Well, it's just the next number. So it's 192.168.1.1. And what is the last host? It's the one right before this one, which is 192.168.1.126. And there you have it. You have the very first network completely filled out. Okay, what about the next one? It is a /27. So remember, a /25, you divided the /24 in half. So we had two ranges. Well, a /26, you would have 4 ranges because you're slashing both of these in half, or you're doubling the amount of networks. Well, that was a /26. A /27, we have 8 networks. So a /27, we would have to list all the ranges here. Okay, so let's say you had to figure out what the ranges are. Now remember, a /27 actually has 32 addresses in that range. So we are going to do ranges, and I'll just start from the very beginning. The very first range would be, and basically I'm going to ignore this for now, and I'm just going to put the very first range that would start with 0. So we would have 0. Now, how do we do our ranges? Well, you know that it's 32 hosts, 32 addresses in each range. That means that our ranges are only going to have 32. So an easy way to determine that would be to just add 32 in each row. So 0 plus 32 is 32. 32 plus 32 is 64. 64 plus 32 is 96. Okay, and we'll continue that in just a little bit. But another way, and another thing that you want to know is, well, how does that range end? Well, basically, where this one begins, right before the other one ends. So it would be 0 through 31. 64 is the first of the range, so that means that this one ended at 63. 96 is the beginning of the next range, so 64 ends in 95, and so on. So here are the ranges completed. Okay, now the question is, how does that relate to what we're doing here in subnetting? Well, we used 0 through 127 already, so we cannot use those. We have to use other addresses for this other network. So we're going to move on from here to using the /27. Well, this one ended at 127, so that tells you that the very next address that you can start with is 128. It is the address right after 127. So that tells you that you're going to use this range here. So the very last address is 159. The address before that is 158. And then the address after, because remember now we need the first host in the range, so it's the first one after 128 is 129. And now we have the address ranges for the very first network and then the very second network. Now we need to move on to the third network. For IT, we need 10 hosts. So what is it going to start with? We know that this one ended at 159, so this one's going to start with 160. Well, if you do a /28, you actually have 16 hosts. So that's going to be a lot of networks. And it's going to double this one. It's going to be 16 networks. So I am going to use this chart that I created here that has all the many ranges. So let's look at what we've already done. We've already used 0 through 127. So we use this range here. Remember, it was the /25. When we used the network mask or the subnet mask as 128, just like here. And we used 0 through 127 as the entire range. What about the second network? We used /27. Let me go ahead and highlight these two. We used a /27. We started with 128 and ended with 159, so we used this one. We know that we have a /28, and we're going to start with 160. So if we go to /28, and which one starts with 160? This one here. I just haven't completed the range. Remember, where one ends, the next one begins. So this one ended at 159. So this one starts at 160. So this 160 here, since this one begins at 176, this one is going to end at 175. So that will be our range here. So it starts with 160. It ends with 175. The last host in the range, remember this is a range from 1 through 126, 129 through 158. All of these can be assigned to hosts or devices. So the broadcast, you subtract 1, and this would be the very last address. Then you get the network and you add 1, and that will be the very first host. Good, we're almost done here. So we know that this next network with 2 hosts, bit prefix of 30, and a mask that ends at 252, that one will start with the next number. So it's 192.168.1.176. Now, when it's 2 hosts, it can actually go really far down, but it's not difficult because we only have 4 hosts, or we have 4 addresses in this range anyway. The first one is the network, the last one is the broadcast, and then the 2 in between. So all you really need to do is increment 176, 177, 178, and 179 is the last one in that range. 2 plus the network and the broadcast is 4 IP addresses. And that is it. That is what you need to do to subnet a range of addresses that are given so that you can separate the different types of hosts you have. And one thing I didn't mention is, well, why do we want to separate? Well, think about HR. What kind of information does human resources have? They have your salary, they have your social security number. You don't want everybody to have that information. So we want to have we want to organize them in a way that only HR has access to that kind of information. Or IT, they have access to, things that you can do with your computer, and, a lot more access and security. So you want only certain things um, that IT can do. You probably don't want HR to have access like IT, because, well, they might do something wrong with the system. So anyway, so we basically want to divide the different departments so that we have security requirements. Okay, and lastly, I just want to show you this chart here. Remember at the very beginning, I showed this very first one. If it was a /24, let me go ahead and make this bigger. If it's a /24, you actually have 256 addresses. And remember, you need to subtract 2. Let me see if I can get that arrow again. You have a network address /24. That means that you have 256 addresses, but your number of hosts, you have to subtract 2, because you need to reserve the very first one for the network, which is the .0, and the very last one for the broadcast. And if it's a /24, you have all 0 through 255. So the very last one is 255. Everything in between, .1, .2, .3, .4, .5, all the way to 254 can be assigned to different devices, different computers, tablets, cell phones, everything that would be connected to the network. Okay, then we have a /25. You have a network address. So this one starts with 0, but also note, since it's a /25, you have half the amount of /24. So you only have 128 minus 2 for the network and the broadcast. So it's a total of 126 to assign to devices or hosts. And you just keep on dividing, /26, /27. Notice how it keeps on decreasing as the bit prefix increases. And that's pretty much all. Best of luck.